Hello to everyone who's joined us this, well, it's 2 o'clock, so it's my afternoon, but I appreciate it's not everybody's afternoon. I'd just like to really welcome Tony Cotton. If you've attended one of our many maths webinars before, you may well have already heard from Tony, but his expertise and knowledge it's wonderful to hear his thoughts. And I'm really interested in these 4 days of webinars because we're taking maths at a very broad level, not specific things as to how to teach fractions and things, but really some of the broad topics. So I will just hand over to Tony just to let you know that there will be a certificate coming out to you at the end of the webinar, and you will receive a copy of the slides. So Tony, thank you very much indeed, and enjoy the webinar, everyone.
Thanks, and it's lovely of you to say all those very nice things. I always start these webinars off feeling kind of slightly overwhelmed and very humble, just because of the kind of importance of bringing this number of people together. And it always, I ran a webinar last week, and we had people from Iran and Iraq and Afghanistan in the webinar. And today we've got people from all over the Caribbean, from the UAE, from Saudi Arabia, from Bangkok. So literally all across the world. And just special hello to the people from Ukraine. And it's kind of a reminder that whatever is going on in the world, education remains something that's absolutely vital and something that can bring us all together in a shared endeavour. So I do hope you find something useful in what we'll be saying over the next 4 days. And it would be nice to, if some of you are attending more than one of the webinars, hopefully we can get a real feel of togetherness across the 4 webinars. I'll see if I can remember rightly. I should have written this down. I know today is about looking at the real world and teaching mathematics. And maybe more than that, it's thinking about how we can become more mathematical in the real world, whatever form that real world takes for us, and how we can support our learners and our students to see the world in a mathematical way, and to be able to use mathematics to act on the world, to make decisions about what they're going to do in the world, to make the world kind of a safer and better place for all of us, wherever we happen to be. Tomorrow is around inclusion, and I'm running tomorrow with a colleague and friend called Andrew Jeffrey, and we're going to be looking at inclusion in general and kind of the philosophy behind inclusion, and then very practical ideas about how to support individuals who have particular learning needs at particular times. And that's one that I think me and Andrew are particularly interested in. I'm actually autistic, and Andrew has ADHD, so you get a little bit of a slant from those 2 points of view. Then Wednesday is about well-being and mathematics, and that's me again, and thinking about how we both look after our own well-being in through teaching and learning mathematics, and how we can support our students' sense of well-being in mathematics and through mathematics. And then Thursday, a colleague called Charlotte and Andrew again looking at teaching maths through stories. So in a sense, it's a really nice little course. I think it's a really useful course of 4 sessions that should really, I hope, give you something to think about. I'm glad you love maths, Charlene. So do I. And hi, Tetiana, another colleague from Ukraine. So lovely to have you with us. And our first person from Brazil. Hi, Elisa. So let's start thinking about the real world and teaching mathematics. And just a little bit about me to start with. I would be interested, again, feel free to be putting things in the chat all of the time. I'm getting quite good at looking at the chat whilst talking. I remember before my very first webinar, which will be about 3 years ago now, I asked my son's advice. Hi, Marcus in Bangkok. about what to do when you do webinars, because he's a politics lecturer. He was giving me advice, and he said, whatever you do, don't look at the chat, because it'll put you off. And maybe parents are a bit like children. You know, children always rebel against their parents. Maybe I was rebelling against my son in wanting to try and run the chat alongside. It does give me a sense of actually talking to people. I feel like I'm talking directly to you, Elisa, in Brazil, and Maria in Chile, and Bengi in Turkey. So it feels that there's a sense of community, hopefully, by seeing you in the chat. So if you've been to any of the webinars that I've run before, just say yes in the chat, or which one you came to. So that, again, gives me a sense of who I'm talking to. And if you've been to any of my sessions before, some of this you might recognize. Most of it, I think, will be different. But you'll certainly recognize that phrase. Great, Charlene. That's good. I hope it'll be more than 4 after this one. So I teach mathematics. I enjoy teaching mathematics. I get excited by being in any sort of classroom, whether it be with 4-year-olds or 8-year-olds or 16-year-olds or 25-year-olds, or the whole range. I noticed this morning there's an organisation called the University of the Third Age in the UK, which is kind of a university for retired people. And I suddenly thought, oh, I know, I could run a maths session for these people. So I'm always looking for hi, Michelle, lovely to hear from you. Always looking for opportunities to teach mathematics. And one of the things, what you have there are images of the people who teach me most about the teaching of mathematics. The right-hand side is a classroom in Jaipur in India. That was my last trip before lockdown, and that's a school there, sitting with, I think they're about 9 years old, maybe 10 years old group of learners. And as often happens when I visit schools, you end up being given an impromptu lesson to teach, and I was very happy to do such a thing. And I've been lucky enough to teach in something like 25, 26 different countries. And I think what I learned from that is how common our aims are for education, how common our aims are for teaching mathematics, because that's what I do, and how common I suppose our challenges are, what we're interested in, and what we're interested in improving in terms of our own practice, and kind of my confidence that between us as teachers all around the world, we are creating a better place for all of our children to grow up in. There are hiccups, there are big difficulties, there are times of huge challenge for particular people in particular parts of the world, but hopefully through education we can ever so gradually move towards this better world for the sorts of people who are in the left-hand picture. Those are 3 of my 4 grandchildren. There's been 2 grandchildren since I first started these webinars, so I'm going to start getting bigger slides. They all live in a place called Glossop near Manchester, and that's up in the hills near Manchester. And I think I'm very conscious now when I'm doing these sorts of talks of children like that all around the world. I can imagine children like that in Oman, in Jamaica, in Istanbul, in Hanoi, in Kiev. And children of that age are the same, aren't they, all around the world? And they deserve the same, and they deserve the same focus from us in terms of their mathematics. The second paragraph, second sentence, I believe our understanding of mathematics impacts on our understanding of the world. I've used before in these webinars, but I think it's worth repeating, the way that some of us were able to use our understanding of mathematics to negotiate our way through the COVID pandemic. And that was probably the biggest mathematical problem that all the countries around the world had to solve, and on the whole have solved it through the use of mathematics. And that was it. It's in the obvious way of developing vaccines and all of those sorts of tests, of developing policy and seeing if that policy did have an impact on infection rates, and measuring infection rates is mathematical. Hi Terry from Qatar, and hi Phong Pham from Vietnam. Thanks for joining us. But it's also through people using their own mathematics to think about decisions that they might need to make. And that's where mathematics starts to have something to say about, I suppose, about fairness in society. So I was running various workshops, online workshops for students and for their teachers. And one of the things I suggested was a mathematical model for the spread of infection. And it actually made its way into some textbooks that I've written for Belize, the BZ math books. This activity is in one of those books. Say you have a class of 35 students. You get all those students to come out to the front of the room, or take them all into a hall. You could even do it in an assembly with a large number of students. 100 would be perfect. All of those students have got a small piece of paper, wrapped up, screwed up little piece of paper. And you just give them one of those each, and they move around the room, and you ask them to stop and then pair up and all open up their pieces of paper. Now, these have been pre-prepared, so only one of them has got a cross on their piece of paper. And the other person in the room who's paired up with that person puts a cross on their piece of paper. They have become infected because they've met an infected person. And you repeat that. Of course, there are now 2 people with the infection, and repeat it for 4 or 5 rounds. And at the end of that, depending on the age of the students, you can ask them to predict, what do you think, how many people do you think now will have crosses on their piece of paper? How many people do you think will be infected? And you could work out a maximum and a minimum. There's all sorts of different questions that you could ask. And then you open the pieces of paper and actually see how quickly that virus has spread. And that's quite powerful in terms of thinking how quickly viruses spread. But you can develop that. And you can start to say, okay, but what if we take some precautions? Let's imagine that washing our hands carefully reduces the chance of infection by half. So then you repeat the model, the experiment, and this time roll a dice, and you only catch the infection if it's an even number. So now you're bringing probability into the equation, into the lesson. You could go further. You can say, okay, well, let's say washing hands and wearing masks reduces the chance of infection to 1 in 6. Now roll a dice, and you only catch the virus if you roll a 6. Say. You could start to say, if you have an injection, if you have a vaccination, it reduces the chance of infection to 1 in 10. And now you could use digit cards, and you only catch the infection if you pull out a 5, say, of the 0 to 9 digit cards. And what that does in terms of the mathematical model is it gives quite a powerful message to people about how you can make decisions which will reduce your chance of infection. So that's a way that mathematics is both used in the real world to find out data which tells us what's going on, and if there is an impact of people taking precautions, but also hopefully persuading individuals to take precautions, because that will reduce their chance of infection. So that's one example of how mathematics is both used in the real world and can be used in the classroom to help people make decisions about their real world. And the second one came to me while I was looking at that image on the left-hand side. That's Felix, Tate, and Quinn, in order from the back. Felix is now 9. Tate is, with his Superman, I thought Spider-Man perhaps, is 5, just 5, and Quinn is 2 at Christmas. His birthday is Christmas Eve, 2 on the 24th of December. And that made me think about climate change and the topic of climate change. And one of my jobs is I edit a journal called Mathematics Teaching in the UK, and there's been a lot of teachers starting to think about how they can teach about climate change. When the three of them last visited 2 weeks ago, I live in a place called Otley, just north of Leeds, in the north of England. We went to see a film, and it was about Antarctica, and it was about global warming, and there were images of the ice shelf melting and falling into the sea, and the seas rising. I haven't noticed anybody joining from Pakistan, but they're the latest country, aren't they, to be incredibly impacted by the changing climate and the changing the weather. And in that film, it talked about whales being a good source of carbon capture. Now, whales eat plankton, the animal whales rather than the country whales. Whales eat plankton, and plankton eat smaller organisms which absorb carbon under the sea. And apparently a whale can absorb 30,000 tons of carbon. Now, when I say that, it sounds impressive, but kind of doesn't mean anything. And that's what I was thinking as I watched the film. So I did a bit more research on that. And by my calculation, that means a whale is worth something like 1,800 trees in terms of carbon capture. So we could, if we save one whale, it's the same as planting 1,800 trees. But still, that doesn't really mean anything. While I was thinking about that, one of the activities that a teacher had suggested that written for mathematics teaching was about counting trees, about getting a sense of how many trees fill a particular space. So I thought, well, we could do something about this in a classroom. You could ask your students tomorrow, how many trees do you think would fill our classroom? And they would say to you, well, what sort of trees do you mean, Elsie? What sort? Well, they would probably say, Mrs. Pepito. What sort of trees, Mrs. Robinson? What sort of trees, Mr. Roberts? I'm an Anthony as well. You've either got a very nice double-barreled Roberts surname, Anthony, or that's what your signature is. And another Roberts, another Ansaki Roberts from St. Vincent. And you could say to them, well, what you decide on what sort of trees, and you could focus on a particular piece of rainforest. You could focus on trees in Jamaica, in the Blue Mountains. You could think about those trees, and then you could research. You could work out how many of those might fit in your classroom, because you could find out from the web how big those trees are. And once you decided how many would fit in a classroom, you could use that to think, well, how many would fit in the school hall? How many would fit in the schoolyard, in the school playground? I live, lucky enough to live, if I look up in that direction, I can see it's a very old wood. It's probably, it's thousands of years old. I'll not begin. The Roman soldiers, when they were occupying the UK, used to march along the top of the wood, and those trees would have been there, or their forebears would have been up there. So in a school in Otley where I live, we could work out from that, we could get a map and think about how many trees would fill or on the Chevin, which is the hill, and then we could think about transporting that to the rainforest. So we're using scaling all of the time to think about it, and then we get a sense of how many whales is equivalent to the rainforest. But then we get a sense of actually being able to do something about climate change. So it's the same sort of example. What we're doing is we're doing mathematics, which allows us to make decisions about how we might act in the world, whilst modeling the mathematics that people are actually doing, that climate change scientists are actually doing, to try and fight climate change. So two quite important examples of the way that mathematics both allows us to make decisions, but is actually used in the real world. And so in that sense is really important. So whilst we're thinking about the real world, I'm talking about mathematics as if everybody knows what we might mean by mathematics. In the chat, and I want to involve you in the chat fairly often if I can, think of somebody that you know, and again, you may have done this in a previous webinar. If you have, that's fine, because you can use that same person. I want to build up an image of the skills and aptitudes that confident mathematicians have. And we're going to do that by you thinking about somebody you know that is confident in mathematics, and think of that as an actual person, and write in the chat the sorts of things that they do which lead you to think that they are confident in mathematics. And then I'll share with you somebody who I think is developing as a confident mathematician. Okay, so if you can start putting those things in the chat, and it gives me a chance to have a slurp of water. Welcome, Rena. Hi, Temitope. Whereabouts are you joining us from, Temitope? Thanks, Rosalind. So somebody who can think logically, get reasons to support their answer. Quickly do mental maths. Other things. So for Melissa and Norda, I'm going to say something about practical and something about real world maths. And you kind of use it confidently. While you're writing, replying to Norda, who says, maths is a practical subject. We use it in our daily lives. The dressmaker uses it measuring along with the baker and the builder. One of the features that I've started using in mathematics teaching, the journal I talked about, is quite a long interview with people who might not see themselves as mathematicians, but use mathematics an awful lot in their job and in their day-to-day lives. And so far, I've talked to a sculptor who talked about how he wasn't very good at maths at school, but clearly somebody who's a skilled sculptor uses mathematics all the time. And a playwright who is using mathematics to create plays that they take into schools to allow children to develop things like logical and critical thinking. Strategic. Analyzes problems. Thanks, Cheryl. Other things. Oh, I've nudged that on with my hand. What does your sports teacher do, Julia, that shows you that they're a confident mathematician? Articulate patterns. I'm going to wait for Julia to get back to me about her sports teacher. While I do, I can remember once visiting a school, and I was meeting their head of mathematics. Okay. Yes, using statistics to improve teams' performance. It's a film and a book, isn't it, called Moneyball, which is all about using particular statistics. See patterns. And me and the head of maths spent some time in the entrance hall we were throwing a tennis racket to each other and spinning it to see what sort of parabola it formed as we span it, and if we could track a particular point on the tennis racket. Yeah, thanks. There's something about enthusiasm, isn't there? I think Eddie Wu used an example from one of my books about 3 weeks ago now. It was quite exciting. I can explain clearly. So I'll just read through some of those that I've jotted on a piece of paper. So something about logical thinking. Okay, and so they've got a sense. Sorry, Julia. They've got a sense of estimating distance and space and those sorts of things. Oh, embraces challenge. That's great, Abigail. Thanks. They think logically. They can carry out reasoning. They're good at mental maths. They're not kind of scared to try and work things out mentally. They use maths in a practical way. They use maths in a real world way. And I suppose do that confidently, do that without worrying about it. They're critical thinkers. They can use their maths to think critically, which is kind of the example I was giving with COVID and the trees. They're strategic thinkers. They can analyze problems and understand the mathematics that they need to use in order to solve those problems. They're enthusiastic about mathematics. They can explain clearly the mathematics. They see patterns and they can articulate the patterns that they're seeing, and they embrace challenge. Now, there was more in there, but isn't that a fantastic list? And I've said this before, but I'll carry on saying it. Wouldn't it be great if that list was on your classroom wall, or a similar list to that, and that what you could do and what the school could do is think, how am I teaching those skills? Because if I'm teaching those skills in my mathematics lessons, my students are much more likely to use their mathematics for solving problems in the real world, become confident mathematicians. And if we're confident about our mathematics, we will see the world in a mathematical way, because that's what we've become used to, seeing the world in a mathematical way. So think about the last mathematics lesson that you taught. Might be today, could easily have been today. And just bring that to the front of your mind. And I'm going to read that list again and think to yourself, did I teach any of these skills through that mathematics lesson? If I didn't, which of them maybe could I have taught in that same lesson, just by a slight shift in focus? So did I teach my students to become more logical in their thinking? Did I ask them to give me good reasons for their thinking, to develop their reasoning? Did I ask them to use mental maths? Were they encouraged to use mental maths? Did I teach them how to use mental maths in a better way? Did I show them the practical uses of the mathematics I was teaching, or the real world applications of the maths I was teaching? Did they become more critical in terms of their thinking, or more strategic in terms of their thinking because of that lesson? Did I expect them to analyze problems? Was there an opportunity for them to be enthusiastic about what they were discovering? Was I enthusiastic in my delivery of the lesson, in what I was talking about? Did they see somebody who was enthusiastic about mathematics? That's maybe one of the most powerful things we can do with our students, is be enthusiastic ourselves, be learners ourselves, show the learners how brilliant it is to learn mathematics. Were they given the opportunity to explain what they're thinking clearly? Did I support them in learning how to become more clear in their explanations? Were they encouraged to look for patterns? And if they saw patterns, were they encouraged to articulate what they were seeing? And maybe finally, were they encouraged to embrace challenge? Was the lesson challenging? And if it was challenging, how did I support them in embracing challenge? And that just gives you a slightly different way of looking at the lessons that you teach. One of the other things that you will know about me, if you've been to my webinars previously, is that occasionally you will look, and it probably tells you there's 16 slides in the presentation, and we're halfway through and I've done 3. I tend to talk a lot about the slides at the beginning, and then we see where it takes us. I always think that the slides are kind of a structure around which we hang stories, really. And it doesn't matter whether we get through all of them or don't get through all of them. What matters is if something that I do say over the next in the hour impacts on you in a way that means you want to change something about what you do, and that's success. Me going through all of the slides in an hour, spending exactly the same amount of time on it, and imparting knowledge that had no impact on the way that you taught would be failure on my behalf. There we go. A developing confident mathematician. And let me tell you this story. and hopefully give you an activity as well. Another thing I try to do is make sure that you have activities that you can try in the classroom. So that's Tate. He was 3.5 years old when we were playing this game. And it's a game from a colleague in Australia called Michael Minas. If you Google Michael Minas and love maths, I'll put it in the chat. You'll find lots of great games to play. And this one's called Place Value Pebbles. And you can see that there are 10 pebbles. I've written 10 in the bottom left-hand one as we look at it, and 100 in the bottom right-hand one as we look at it. We used playing cards, probably easier in the classroom to use 0 to 9 cards, digit cards, 0 to 9 digit cards. And the idea of the game is you turn over a pair of cards, only 2 cards, and that means you have a choice of 2 different 2-digit numbers to make. So, for example, at some stage, Tate will have turned over an 8 and a 1, decided to make 81 and put that in the, you can see on the right-hand side, he's written 81 in that pebble. And what you repeat this 10 times, and what the aim is to make sure that your pebbles go in ascending order. He was using a 0 to 100 square, another useful representation of the number system, to help him work out the order of numbers and what comes before and what comes after. You spell his first name T-A-T-E. So you might notice that he's reversed the A, and it's kind of a mixture between a reversed 9 and another E, almost as if he kind of had a sense it wasn't quite right. And his surname is Morris, and he's reversed the S at the end of his name, and it's become the digit 3. You may also notice that in the pebble top right, just one down, that he's written 1-5 in the pebble. So he turned over a 1 and he turned over a 5. And he wrote that 1-5, but he said 51. I wrote the 5 and the 1 above the pebble, and I said, what number's that? And he said 51. And I said, what number have you written? And he said 50. And then he paused and he said, how do you spell 51? So he's at that stage in his mathematical thinking in terms of place value where he's thinking about digits as having the same sort of way of working in language as letters do. How do you spell? So he doesn't necessarily know that if you write a 4 and then a 3, that's 4 10s and 3 1s. He sees that as a way of writing down the word 43. But he is understanding the order of those numbers because he has another representation of the place value system. And he's happy in working in that way. He's embracing that challenge, to go back to your words. So he's feeling comfortable trying to work this all out for himself. So the 3 that he's used to spell Tate Morris kind of has the same value as a S, as an S. And he will develop his understanding of place value. Alongside that, he asked me the question whilst we were doing this. He said, how old are you, Grandad? And I said, I'm 62. And he said, is that a big number? And we looked at the 100 square, and I said, it's quite a big number. You know, it's towards the end of the 100 square. And he said, okay, he seemed happy with that. And then he said, how old was Grandad Bill when he died? And I said, he was 89. And he said, that's a big number, isn't it? Because we could find it. So he's already at the age of 4.5, using his developing understanding of maths to actually ask quite big questions about the real world. How old are people when they die? Is that a big number? Is that old? The next morning, he's making pancakes with his dad. His dad's a chef, uses lots of maths in the real world. We'll come back to that in a moment or two. They were making pancakes, and he needed 120 grams of flour, and they're using some digital weighing scales. Pouring the flour in, and Ben, his dad, is asking Tate to count out each time he stops, and count. Tate's 72, 83, 92, and then he stopped again. He said, "What number's that, Daddy?" And Ben said, "It's 106. And Tate turned to me and he said, "Grandad, there's numbers bigger than 100. So again, through the real world this time, he is developing his understanding of things like counting. He's starting to see. And since then, well, and before then, actually, he notices numbers all around the place. And he even knows that we use numbers for different things. So when we see a 3, 4, 9 on the front of a bus, it doesn't necessarily mean it's the 349th bus. It just means that particular number refers to a destination. Whereas numbers along a road, house numbers, do mean there's a particular number of houses before that. So from very young, children are using their mathematics to make sense of the world. We don't have to teach them that there's a link between mathematics and the real world. They understand that. Hi, Adira. Welcome. Where are you joining us from, Adira? And maybe one of our jobs as teachers is not to separate maths from the real world once children start school. Is that we don't give them the signal that mathematics is no longer about the real world, or that school mathematics is somehow different from the real world. I'm going to jump a slide. So that's one of my senses of what mathematics is. That's a phrase that I put together for some writing I was doing for a previous book. It was an early years book, and I was trying to look at what different countries, how different countries termed mathematics. So this is taken, I think, from 6 different countries' mathematics curricula. So this is what I think mathematics is. This will be on my classroom wall if I had a classroom. We use mathematics to explore and explain the worlds we live in. 2 functions for mathematics. It allows us to explore the world, and it allows us to explain the world, explain things clearly. And we have different worlds. We have social worlds that we operate in, we have political worlds that we operate in, and we have creative worlds that we operate in. And we apply mathematics to all of those different worlds. And I'll talk a bit about this idea of an imagined real world later on. Mathematics is about relationships, and it can be about numbers, but it's also about shapes, and it's also about measures, and it's about how all of those things relate together. It's about classifying things, putting things in order, and about making general statements, generalizing. And it's learning to explore and solve problems. And I think that last part is important. It's about exploring. Sometimes just the exploring is joyful enough. We don't have to solve something. Let's hope that works for you, Temi Tope. And again, I'm going to jump a slide so I can talk about the imagined real worlds, if you like. And these imagined worlds can often be as real to particularly young children, as actual real worlds. That they get very engaged, don't they, in imaginative play and in thoughtful play. And there's mathematics in that. There's mathematics in that thoughtful play. So this is from a site called UCubed from Harvard University, and this is something that I was using in lockdown. I was doing a lot of teaching to students from Felix's school in lockdown, and they all ended up joining me with their parents. It's usually about 11 o'clock in a morning that the class gradually built. And the task started off, and it's one of those kind of real world problems, but it's not really a real world thing. I think we quite often invent real worlds, don't we? And the task was to create a parade of 20 animals. Maybe you just spend 2 minutes. Can somebody tell me what their parade of animals would be that had 20 legs? So just put me some answers in the chat. I want a parade of animals with 20 legs. It is Joe Bowler, Elisa. Yeah. Sorry, Stanford rather than Harvard. Yeah. And all those materials are free. So it's a great site to go on. Do you use it? So type in for me. Great. A parade with 20 legs. Five moose. Thank you, Maria. I used to work with Joe. We both did our PhDs together many years ago with Joe. So I've known Joe for a long, long time. You can have different animals. Horse, goat, elephant, donkey, sheep. So straight away, what's great is that Sarah is adding on different animals, 10 chickens. So 10 chickens are equal to 5 moose. Unless the cats have only got 2 legs, I reckon that's 40 legs from Michelle's, but we could 10 ostriches, 2 octopus and 2 ostriches, 16, 2 octopus, 2 stork. So we're starting to become a bit more complex. And actually what we're doing, Atik and D. Douglas, we're starting to think about algebra, aren't we? Because what we're starting to do, and these kids were aged, I think 6 when I was doing this, we're starting to think about how many, 5 cats, thanks Michelle. I said it wrong as well, didn't I? We're starting to think how we might represent that. So 4D plus 1C equals 5C, for example. 2O plus 2S equals 5C. There's any number of ways we can start recording that. And we're starting to think about number bonds. Because of the clever way that this is set up, we've got a snail that equals 0, which I quite like. What Felix and his friends started to do was invent new animals. So that they had an octomoose, which had 12 legs, and an octostrich, which had 10 legs. So at one point, Felix said, 2 octostrich. And off we went in a different direction, because the kids were taking control of what was going on. So they were becoming enthusiastic about what was happening. They were able to explain clearly what they were doing, because I was like, what's an octomoose? And they had to start to explain that. They were certainly seeing patterns and articulating patterns. I think they were embracing challenge. I think they were being encouraged to use mental maths. They were certainly being logical. So within that fairly straightforward activity, they were able to use mathematics in their imagined real world to solve problems. I think it is, Maria, isn't it? And not complicated, and good fun. And so much better at thinking about number bonds than just saying, can you write down how many different ways all the number pairs to 20? And you know as well as I do that if we do that, quite often, lot of students will do is write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 down one side of the page, plus, all the way down the other side of the stage, and then page, and then 19, 18, 17, 16, because they've kind of seen the pattern, and they're just reproducing what they've seen rather than thinking about it. And this version of the real world allows them to think about it. Somebody mentioned dressmaking, cooking, building, creating, and all of those things having mathematics in them. And we can use all of those examples in the classroom. And what that does is make a direct link between school mathematics and real mathematics that takes place in the home. And there's Felix making, he's actually making some jerk chicken. One of the other projects that we did in lockdown was thinking about a country that you might want to visit and doing research about that country. This was with all of his friends, and he researched what the currency was and the exchange rate, how far away it was, how long it would take to get there, how much different things cost in Jamaica compared to the UK, and cooking foods that he saw from Jamaica. And of course, there's an enormous amount of mathematics in cooking food, and it starts to give you a sense of measure. And I think one of the most important uses of measure, reasons to teach measure, is that we understand how measure operates in the real world. And I'll show you an example later on of what this kind of looks like in terms of an activity in Max Maths. Some more examples of everyday experiences. 3D shape, making 3D shape, and 2 examples there of shape. One of the things that I've been lucky enough to do over the last 4 years is work on a series of books for Belize called BZ Math, and it's lovely to have so many of you from Belize here. And I don't know, some of you might have been, hi Kerry in Jamaica, some of you might have been in a very early webinar I did when we were talking about teaching and learning shape. And I said, you need to send me some photographs of shape in your environment so we can think about the sorts of shapes that we can see. And wherever you are sitting, wherever you are in the world, you will be surrounded by shapes. So I'm trying to see what you can see in the back. You can see the beginnings of a cone. We're doing some building at the moment where my mother-in-law's moving into our house, which is why I've got a broken lamp in my room. Lots of cuboids on the bookshelves. You might be able to see a mug over there, which is cylindrical. We can just look around and see shapes all around us. And one of the things I often ask students to do is go for a walk, draw or take photographs of all the shapes that you can see, write about their properties, write down the names of the ones that you know, but always find me shapes you don't know the name of. And we can find out between us what those shapes are called, or we can think of ways of describing those shapes. Maybe that's about embracing challenge, but it's certainly about using maths in the real world. And it's certainly about thinking about patterns. Thinking about properties of shapes is actually noticing patterns, isn't it? And at the top left is a series of images of some shapes that Felix made using some magnetic shapes that you can join together to make 3D shapes. And we had quite a long conversation about the properties of these shapes, not initiated by me, initiated by Felix. He said the cube is somebody's house. So you can see a cube, there's a red square on top at the kind of very top of those shapes. And then next to it, he said, and there's another cube, the yellow cube. And then he stopped and said, it's not a cube, it's too long. So we could start to talk about the difference between that as a cuboid and a cube. And I even talked about a cube being a special form of a cuboid and what's the same and what's different. And we could talk about what's the same and what's different of the other shapes. And because we'd used the real mathematical language from when he was small, he knows what those shapes are. So that's the other thing about mathematics in the real world, is always be real about the names that you give things. Don't be scared about using complicated names for things that are mathematical. Always use the correct mathematical vocabulary. Model the correct mathematical vocabulary all the time, because then your students will be able to describe the maths they're seeing in their real world. On the bottom right hand side, Tate, who you met earlier, was much younger. I think he was probably about 3 years old, and we were on a train. That's a train seat, and he took his croc off, or what he was calling crocs, and he said, "There's threes everywhere." So he's noticing the three kind of holes at the side that you can see. There are 3 lines on the top of the croc. You can perhaps see 3 little red buttons in a design. So he's seeing threes in all sorts of different ways. And then that's modelled in school by all the different ways we can make 5. So there's a mixture there, isn't there, on the left, of real world, going and collecting 5s in the real world, creating different patterns of 5, and then the digit 5. So that Tate has something to relate that digit to. He knows it doesn't just spell the word 5. He knows it relates to all of those different things. And as well as that, he starts to see 5 as a 4 and a 1, or 2 plus 2 plus 1, or 1 plus 1 plus 1 plus 1, 5 in a line. So he's getting a good number sense of 5. Next time you are out, just look round for patterns. If it's possible for you, take photographs of things that you see and bring them into class and share them with the students. We could spend a long time, couldn't we, just looking for shapes in that pattern. That's actually on a coffee shop just down the road from here. I think people in Otley think I'm a bit mad because I'm always taking photographs of things. Well, there's so much mathematics in that image. And part of what that image does is show how many different sorts of triangles there are, how we can make different quadrilaterals out of triangles. I can see right-angled triangles divided up into 2 other right-angled triangles. There's any number of different right-angled triangles in there. There are kites, there are trapezia. There's all sorts of different shapes that we can find. For older students, we can start thinking about similar shapes. And it's quite interesting. I've spent ages and can't quite do it, thinking, where does that pattern repeat? That's why I think it's a really interesting pattern. Can I see what's the basic shape in that pattern? Where did they start off from, the person that was designing that? And I think one of the ways of encouraging students to embrace challenge is to take in things that you don't know the answer to, that you can work on together. And that might be something that we could do together. So what does all this look like in terms of putting examples of the real world into mathematics activities in the classroom? And I'll finish off with 4 examples from Max Maths, which was a program that I've worked on as well. Negative numbers are often seen as something that are very difficult for students, but actually it's something that students think about, I think, from quite young. So thinking about my own kids, Sam, who I talked about earlier on, who's now 35 and has just, with Jasmine, with his wife, got a 6-month-old, our latest grandson called Wilf. And we were on holiday, and they'd all had £10 given from one of their grandmas to spend on holiday. And Sam was spending his money, and he knew he'd got £1.50 left over. And we were in a gift shop at a museum somewhere, and there was something that cost £3. And he said, "Oh, Dad, can you lend me £1.50 so that I can buy that?" Well, that's calculating with negative numbers, isn't it? That knows that £1.50 to minus £1.50 is a hop backwards of 3. I should have asked him how he did it, but I just thought, oh, that's quite, knowing that is understanding something about negative numbers. Making comparisons about hot and cold places is something about negative numbers. We could even use climate change to start thinking about that. We can arrange from coldest to warmest, and all of it using a number line. And if you think about it, a thermometer is actually a number line. So that gets us used to thinking about moving up and down a number line past 0. And that's the introduction to negative numbers. Because we will already taught our learners how to use a number line to add and subtract. So suddenly all we've done is extended the number line. The rules for adding and subtracting haven't changed. We can still do that. Measurement. And I always say, and I'll say often, that the way you learn to measure is by measuring things. And the way I will start measurement is by asking for things that people know the length of. Well, we've not got time to do that now, but you will all in your head have an understanding of some measures. Because I'm English, I know that that's a pint. I have a good sense of what a pint is. I've less of a sense of what a litre looks like. I know what 330 mils looks like because that's a can. So we have a sense of measures. I know that 2 meters is about the height of a door. So I'm able to use these things to help me estimate, which is why rather than it just being lines to measure in Max Maths, it's actually objects to measure with a ruler. And part of what there's a follow on to this activity in a workbook, which is finding things around the home to measure. So a way to teach measurement, length, weight, capacity is to make sure that students are using real things and starting to understand what those measurements are. Otherwise, there is that separation between real world measuring and classroom measuring when all you do is measure lines and nobody quite knows why you're measuring a line. Thinking about area and ways of calculating area. Again, use things that we know. What's the area of a textbook? What's the area of your desk? How many times will the textbook fit on the desk? So you're starting to think about scaling, which takes us back to that activity around trees. And finally, thinking about statistics. And when we're teaching statistics, finding ways that what you're doing is asking real world questions that are of interest to the students. We want people to be enthusiastic. We want them to be posing problems as well. So ask them what they want to know about their class. And then between you can gather that data and create, in this case, a bar chart. But you can be doing other statistical measures depending on the age of the kids. So just some ways of bringing the real world into the classroom. And I think the message there is the most important thing is not to exclude the real world from the classroom, not to present mathematics in the real world as somehow different from the mathematics in your classroom. And I think the last thing, and then we'll just have a few minutes for questions, is that idea that you can both use mathematics to act in the real world and to understand the real world, and that you can teach kids to be able to do that. Okay, I'll stop there, and that gives us 3 minutes. So if any of you have got any questions or comments, do put something in the chat. That'd be lovely if you can put something in the chat.
Tony, I was thinking that making maths part of the real world, it's a great introduction, isn't it? Rather than a textbook that starts you straight away with numbers.
Yes.
Having conversations around maths is really, like you said, I think that's so important. It's making it normal. It's not something that's an abstract concept.
Yeah. That's one of the reasons why that opening spread in Max Maths is always a real world example. So it gives you an understanding of what the learners are bringing. I was running it was a part of another webinar the other week, and somebody said, don't students always need some prior knowledge before they can work on some mathematics? And I said, well, everybody. So Tate has prior knowledge, age 3. Quinn is 18 months old now, and he's not speaking, but he's mimicking the kind of rhythm that his brothers make when they count. So he's beginning to learn about counting just at 18 months he's got prior knowledge. And drawing on the real world allows us to find out what that prior knowledge is, because we know what intuitively the kids can do.
Yeah, definitely.
I think that's what Maria's sending. Yes. Do you want to say how you get attendance certificates?
Yeah, the certificates will come out to you at the end of this session.
Everybody that's signed up, or everybody that's attended. That's great.
Yeah.
Thanks.
Thank you. Yeah. Thank you, Tony. As ever, so thoughtful. I love Tate's realization that numbers went higher than 100. That's just so exciting for him as well. That's wonderful. No, thank you all very, very much indeed for joining. Thank you, Tony, so much for your time. Yes, I agree. I've learned a lot as well. Do join us tomorrow if you can, when we will be looking at how maths is explored through different people and different backgrounds. And as Tony said earlier on today, being autistic or having ADHD or any things that, you know, are you might find have presented challenges in the classroom. I know it will be a brilliant webinar with both Tony Cotton and Andrew Jeffrey. So do join us tomorrow, and the certificates will be coming out to you, and we will be sending you out an opportunity to watch this video again, most definitely.
Thanks very much, everybody.
Thanks very much.
Tomorrow.
Thanks a lot. See you tomorrow. Bye-bye.
Bye.